Hello everyone, my name is Kevin, this is Andres, and this is Steven, and today we're going to be talking to you about reverse engineering of the brain. Alright, here's pretty much the overview of the presentation. I'm going to start off talking about the introduction, then it's going to move on to Andres, he's going to tell you all about global concepts, and it's going to move on to Steven from there. He's going to tell you about the designs that are in place and that we're working on, and from there we're going to summarize everything and conclude this presentation. The big question: why would you want to study reverse engineering of the brain? Well, so far we have two answers to that question. One, it leads to a deeper understanding of the brain, and two, it opens up a lot of possibilities to work on technologies such as computing systems and artificial intelligence. Alright, we're going to go more into detail as to what I was just suggesting. A deeper understanding of the brain. Researchers studying reverse engineering of the brain are going to learn how the brain works, and by doing this, they're going to be able to simulate all the processes and basically why the brain fails and why it doesn't work. And after simulating all these things, they're going to be able to find out potential neurobiotechnology that will help disorders in the brain, either using biotechnology through implants or drugs. Secondly, more about technology. We're going to create general purpose computing systems and AI, artificial intelligence, such as streaming information. The brain uses nerves and neurons to connect the brain to thousands of nerves in your body. And by doing this, researchers using simulation can do away with the step-by-step process that computers nowadays use and replace it with streams of information that are in parallel. So we could study multiple information and a lot more lengthy material. Secondly, nerve cell connections versus signaling switches. It's a little bit like I said before, when it comes to processing information in parallel, using all these connections versus simple computing signaling switches that we use nowadays. Alright, moving on.
For global concepts, we have two reasons why we want to do this. The first is so we can better fix it. Like Kevin was saying, if we understand how the brain works, we can do something to better its function. One of the functions is that for cochlear implants, which we already have, and it's been around for a couple of decades now, the technology, they're getting smaller and they're not as bulky, so they don't have to wrap around the ear. It can be directly placed inside. So me will be able to talk. We can give them a box. The dementia patients can remember. There's a lot of drugs for that, especially for shocking of the brain. Dr. Stephen Hawking actually uses a voice box, the famous voice box. And the way he takes his words is with his tongue. He can't move any part of his body, so inside the tongue he has a switch, and he flips through the words on the screen, and the voice and the box talks for him. But the system isn't perfect. The brain has too many signals, like Kevin was saying. A lot of information is passed from one nerve cell to the other, but all of this happens in an instant of a second. When we put in a computer to analyze what's going on, by the time it picks up on one signal, 5 more have already been processed and carried out. The computer can keep up with that information, which is why we're trying to catch up with that, and that's why it would be better. The second reason for why we want to reverse engineer the brain is for the business side of the spectrum. Like I was saying before, if you can catch up with the brain and on how the information is passed from one nerve cell to the other, you can increase reaction times. For example, if I were to drop a cup of coffee, my foot can get out of the way. A computer can do the same thing, but it will probably lag and it will probably get hit on the tail end. Car companies have been working on this, and there's a collision awareness. I think Mercedes and BM has it, but the system isn't perfect. Why? Because the brain is a lot faster than the computer is for now. The brain, as Kevin was saying, can process multiple information at the same time, while a computer can only think in one straight line. If we can fix that, then AI would be better.
Hello, my name is Steven. I'm going to touch upon neuroprosthesis, and it's using reverse engineering of the brain. So neuroprosthetics are some of the most important and helpful applications for the knowledge gained from reverse engineering of the brain. This definition is by far my favorite. Neuroprostheses are a series of devices that can substitute a motor, sensory, or cognitive modality that might have been damaged as a result of an injury or disease. So this can cause, like Andres was saying, mute people to speak, deaf people to hear, even blind people to see with the proper technology. When we're able to decode all the messages that the brain is sending, we're gonna better be able, to produce microchips that would bypass the damaged parts of the brain that would, say, affect speech, learning. We can also implant them in the spinal cord and perhaps return mobility to people who have been disabled or paralyzed. Cochlear implants, they have been around for a long time, just like Andres mentioned. They've been around since 1956, and as technology improves, they'll get smaller and smaller. Now, they're the most popular type, 100,000 in use since 2006. And this is a picture of one. It works by, say, mimicking the function of the eardrum and the sepsis. I want to say that's the word. And then it will process auditory signals just like your cochlea would. So it would return your hearing function. These are the benefits of neuroprosthesis. Here we have a quote by Ludwig van Beethoven. He describes his experiences after he becomes deaf. And as you can see, it's very, very sad. It says, "For me, there can be no relaxation in human society, no refined conversations, no mutual confidence. I must live quiet, alone, and may creep into society only as often as sheer necessity demands. Such experiences almost made me despair, and I was on the point of putting an end to my life. The only thing that held me back was my art. Thus I have dragged on this miserable existence." So he shared that with us, and as you can imagine, more than just Ludwig van Beethoven. Anybody with a physical disability may feel left out by society or may feel, I guess, trapped in their own body. So if we can return that to them, that would be ideal. And the brain is incredibly complex. That's why we have been so slow in developing our these implants and, let's say, the AI and all of this. We have made some advances, but there's still a lot to go.
Here we go, it's coming back on, and he's back on again. See how he turns?
Hi, Jonathan.
Stop the sucking.
Yeah.
Hi.
Good.
That's
Could you
real good.
hear that? Hi, sweetie. Could you hear that? Hi. Hi.
You got that, Dad, right?
Hi, Jonathan.
Look at that. That's so
Hi.
sweet.
We call that a late Christmas present.
Hi. Good job, buddy.
That's really good.
Alright, so that pretty much concludes our presentation. Here's a brief overview once again in summary. Introduction, global concepts, global design, and we're concluding with our summary. So as you can tell from our presentation, studying reverse engineering the brain will not only better our technology, but it also help us as a species by improving any neurological disorder by using materials that we have already in order to implant it into the humans in order to replace the lost or damaged cells. So the next slides are references, and this concludes our presentation.